I want to share with you a few simulations which I initially created to help myself understand how it is that economic inequality might come about. I decided to make this video only after discovering that the cause is not actually as intuitive as it might seem. Now, this is a topic that has been getting more and more attention lately, and the explanations for inequality as given by those both on the left and on the right of the political divide seem obvious. You might hear conspiracies about how the 1% is trying to subjugate the rest of society as easily as you might hear that the poor are poor only because they don't work as hard as the rest. But could any of that be actually true? A few comments before we begin. I tried to make this video as accessible as possible, so there won't be any abstract mathematics, only examples. Also, a quick caveat, what we'll look at here are very basic models that do not capture the full complexities of reality. So generalizing what we see should be done with caution. Reasoning by analogy can be precarious. Still, I think it's great to exercise our curiosity. I just ask that you also exercise your skepticism. So, first, imagine two players that both have $10. These two players will each stake 10% of their belongings and flip a coin. If it comes up as a heads, player 1 wins the pot. And if it's tails, it's player 2's lucky day. The loser gives up the 10% that they put up, and that's it. Now, more broadly, we can think of the $10 as 10 pieces of gold, or even as some kind of all-encompassing generic resource. All we're really doing is imagining that a player has something to bring to the table, and they can compete with another to improve their own standing, or if they're not so lucky, perhaps not. At the very base of this model is the simple idea that there is competition for finite resources. Let's now introduce more players, and we'll start simulating this game. With more than 2 players, we only need one more rule, and that is we pair off the players for each game at random. Let's begin. Everyone puts up 10%. We randomly pick the first pair, toss the coin, get heads, player 1 wins. Second pair, tails, player 2 wins. Third pair, heads, player 1 wins. Fourth pair, heads, player 1 wins. And the last pair, tails, player 2 wins. The last thing we do is order the players from lowest balance to highest. And then we repeat the process again. So everyone puts up another 10%, and so on and so forth. Let's now see how this plays out over many iterations. I've also taken the number of players up to 100 so that we can see the end result a bit more clearly, but the idea is the same. After one iteration, as we expect, half of the players have lost $1 and half have made $1. After 2 iterations, some have been lucky and have had 2 wins in a row and are up to around 12. Some not so lucky, and they've had 2 losses in a row and are down to around 8. But the majority are at around 10. And so it goes. It looks like even after just 10 iterations, we already see an unequal distribution of wealth. Even this might seem to go against intuition. Without giving it extra thought, you would not have been at fault for expecting levels of wealth around 10 with a bit of noise. And that's the thing though. In a way, we remove the noise by ordering everyone after each iteration. So there will always be a lucky player that has won more games than the rest heading up the list. It's interesting to note that we have generated real inequality with nothing more than chance. Also interesting is the fact that the wealthiest player never seems to get more than around 20, and the poorest never much less than 5. This is explained by the fact that we're always selecting partners randomly, so the wealthiest player can come up against the poorest, and the poorest still has the same chance to win despite having a tiny fraction at stake. If our players were even the least bit rational, the wealthiest would not want to participate in such an unfair game. Why would anyone bet $2 against 20 cents on a coin toss? So the way we'll solve this is, instead of selecting partners at random, we'll pair up only adjacent players. This way, only players with roughly the same balances will be pitted against each other on a coin toss. The other rules remain the same. So we have a slight change to the rules, and the end result is basically that our players are a little less mindless. Let's see what happens now. This is where I had to pinch myself. Under such simple rules and almost fair conditions, this simulation runs away, and it only ever gets more unequal. After 6,000 iterations, the top 2 players have nearly 80% of all the money in the system. No one is lazy, no one is a tyrant, just pure chance generating a seemingly inevitable result. Well, what if competence or laziness did have something to do with it? Can we test that? Let's introduce 2 kinds of players, blue and green. When 2 such players meet, they now throw dice instead of a coin, but it's not a fair game. If the dice lands on 1 or 2, blue wins. If it's any other number, green wins. Call blue players lazy or green players competent, all we're really doing is introducing some asymmetry in outcome while retaining an element of chance. If blue faces blue or green faces green, we'll just toss a coin like before. Let's try it out. For the first pair, we get a 3, so green wins. Second pair, 5, green wins. Third pair, 1, blue wins. Fourth pair, 1 again, blue wins. And the last pair, 4, green wins. We re-rank the players and go again. Now the first pair are both blue, so we toss a coin like before. We get tails, so player 2 wins. Second pair is green, again toss a coin, heads, player 1 wins. Third pair, different color, so we throw a dice, and throw a dice. And reorder again. Now let's see it at scale. I'll just add a white line that shows the balances of a simulation that runs in tandem, where the players are all the same, like in our previous example. This way we'll be able to compare. I have to be honest here. When I ran this the first time, I sort of expected the inequality to be more extreme, but that's not the case. Introducing an advantage for some players simply decides where on the scale those players end up. And we can see that the green players are all bunched up towards the top. The shape of the curve, though, is the same. So you don't need tyrannical rich people at the top. You don't need lazy people to not do their part. It looks like all that's required is competition, finite resources, somewhat rational players, and chance. The phenomenon seems to come about regardless, naturally. On the one hand, this made me optimistic that maybe there's no one out there that has ill intentions. There's no room of villains plotting to take your last dollar. On the other hand, seeing all this also made me a little sad, because it's possible that we're sort of trapped by a law of nature. Many discussions can come out of this, and I'll leave you with a question. Can we think of a way to change our model to stop this runaway effect? So let's go with optimism.